So let's do an overview of the equations that we've actually seen and used so far. Starting on the SUVAT side, we have the displacement equals the initial plus the final velocity over 2. That's the average velocity, which we can substitute in here and have v bar t. This is not given with the IB, but it's just as valid as this. On the more advanced side, we have delta x in place of s, we have VF instead of U, and we have V0 instead of, we have VF instead of V, and V0 instead of U. And down here we similarly have just delta x instead of s, and we have V bar instead of this average velocity. Now to get to position, we don't get to position with SUVAT equations. We get to position by adding in a correction factor, the initial position. We add that term in, and it gives us the position. To prove that to you, we know and have defined displacement delta x as x minus x0. So if we have x minus x0 equals v bar t, then if we add x0 to both sides, you will see we get x equals vt plus x0, the initial position. So this equation will actually give us the position. In terms of our formulas in kinematics, I want us to be thinking about our position and displacement equations and our velocity equations. In every situation, there's a set of equations for both. There's both displacement position equations and there's velocity equation. So in the SUVAT side, we just have delta S, the displacement over time, and on the more advanced side, we're using x, delta x over delta t for the average velocity.